So for this page, they want us to kind of use a graph to answer all these questions. And we're going to have to use like midpoint and maybe distance formula and things like that. So if you haven't looked at videos for those would be really helpful. Number one, let's select all that applied, and then we have a trapezoid, and we can't just like look up the facts for trapezoids and figure out which one's true. We have to look at the graph. And if we're looking at these points, the reason why it's a little confusing is that we have this value is AB, so the x value of B is A, the y value is lowercase b. And for C, it's C minus A, and we're maybe like, what the heck is that? But C is this. So basically what they're saying is that this distance from here to here is A. From the origin all the way to this point, this distance is C. And we're saying, hey, this point right here, it's a different color, all the way over to the next value, this distance is C minus A. So since they're telling us, if C is all the way from here, that means that this distance here has to be A also. If like all of this is C, and this is C minus A, that means this leftover part, the difference has to be equal to A. So that'll help us answer most of these. So it says AB equals CD. AB equals CD. Well, we know that we have a triangle here, right? Its base is A, length A, and its height is B, because that's the y value. So if I make a triangle here like this is A, this is B. The same thing for this one. Right, so if I cut up this one like this, the height of this one is B and the base of this one's A. So that means the hypotenuse, AB and CD, have to be the same. So that one works. We got AB equals BC. Well, this would be equal to, like, the AB is the hypotenuse. It would be equal to the square root of A squared plus B squared. And then BC is just C minus A. We don't really, or I guess you could say C is really B plus 2A. Because if this is all of C, and this is A, and then this is B. This is B, that'd be 2A plus B. And so BC, why not B? C is 2A. So I think you can. I think what we're based on some kind of struggling a little bit. I don't think you have enough information to really conclude that these two would actually be the same. That's what I'm getting at. So let's say AD. This is actually what I was just saying. AD, which is this, is equal to BC plus 2A, and that's true since both of these parts are A and this wheeler part is the same as BC, so that one works. AB is parallel to CD. AB is parallel to CD. Well, hopefully that makes sense. This is not true because this one's pointing this way. This one has a positive slope, this one has a negative slope, and parallel lines or line segments have the same slope, so not this one. AD is parallel to BC. That means that's our bottom line and our top one. And that's true, and how you can tell is that they have the same y values, right? So 0 to 0 means this is a horizontal line. B to B means this is also a horizontal line. So those are parallel. Number 2, it's asking us what type of triangle this is, and essentially we have to, we have to figure out the distances between these. So we got to use the distance formula between all of them. So between D and E, how we would do that is what's the difference in the x values? Well, from 1 to 16, that's 15. So 15 squared. 19 to negative 1, that's a difference of 20 plus 20 squared equals the distance squared. That would be your hypotenuse if you graphed it. So 15 times 15, 225. 20 times 20 is 400. So our distance squared is 625 equals distance squared. So the distance between, if you square root these, the distance between D and E is 25. Right? So we got between these two is 25 units. So now we got to do the other ones. Let's do E and F. Well, 16 to -8, that's 16 plus 8, the difference. Remember, this is on the opposite side of the number line. So this is 24 squared. -1 to -8, that's a difference of 7. They're both on the negative side, so it's only 7 equals the distance squared. 24 times 24, 576. 7 times 7 is 49. Ooh, that's going to give us the same thing. This adds up to 625. Square root it, you get the distance is 25. Okay, so far, we got two sides that are 25, so we're at least isosceles. Now we got to do D and F. 1 to -8, that's 9 squared, plus 19 to -8, that is 27. Yep. Just double check. That's 9. That's 27. So that'd be 49. Right. So 27 times 27. That is already 729 plus 49. Okay, so we know this is not going to be the same. Right, so we got two sides that are equal. So we can get rid of equilateral, which means all of them are the same. We can get rid of scaling, which means all sides are different. And now we got to figure out if this is a right triangle or not. And what you can imagine, actually I was going to say something, but I guess, how would we check if this is a right triangle? Well, let's find the slopes of all the lines. I know this seems like a ton of work, I'm sorry. So let's find the slopes of all the lines. And are any of them opposite reciprocals? I was going to say, like, you know, what if we have any similar x values or y values to see if we have a straight line, or we could have a right triangle that looks like this. So we got to find all the slopes of these lines. Alright, well, difference in the y's, if I want to make this 0.2, 0.1, y2 minus y1, this would be -20, x2 minus x1 over 15. So that's the slope of E, which would be -4 over 3. So now let's do the slope of E. Make this 0.1, make this 0.2. -8 minus a -1. This would be -8 minus a -1. So minus a negative would be plus. So that'd be -7 over -8 minus 16, which would be -24. Let me just double check that I did that right. Yeah, that's good. We can't simplify that one. So now we got to do our last one. Let's make this 0.2 and this 0.1. So we got to do E and F. Or D and F, I mean. -8 minus 19 is -27. -8 over -1 would be -9. This would be 3. So none of these slopes are the same. None of these slopes are opposite reciprocals, meaning the perpendicular. Why are we looking for perpendicular? Because that would be 90 degrees. So we got an isosceles.